Hello guys, welcome back to MathZone African Motives. We are still on our mathematics grade 10, still working on our revisions. So these are number patterns that we're going to focus on as a revision as we have checked into the questions like as a topic. So now we want to see how do they ask these typical questions on question number 3, that is 3.1. You are given here your friends Zain and Letty have been trying to solve an exercise, okay, based on the following sequence. This is the sequence they have, okay? Letty says Tn is equal to 4n minus 2. This is Letty's answer, okay? Then Zain says that Tn is equal to 4 into the bracket of 4 into n minus 1 plus 2. Who is right? Use algebra to justify your answer. Okay. In this simplification, you are told to use the algebra to justify our answers. All right. Meaning to say this is just a normal algebraic question that is, yes, under a certain number pattern, but the question here is on the algebra. This first part is on algebra. So how are we going to justify this, that these two are right or who is right? All right, in the first place, if we are to check here, truly we've got a difference of 2 and so forth, we can calculate our Tn. The normal way that we are supposed to have our Tn, we know that, remember, we are supposed to have this in the form of Bn plus C. This is just for us not to have confusion. Actually, we shall see that if you reach grade 12, we shall be having a different formula, but this is just for you to have a basic understanding for your mathematics grade 11, because we remember we shall talk about this an squared plus bn plus c, which is a quadratic. So they want you to just have this format, an squared plus bn plus c like this. So this is the linear part, this one, bn plus c, like this part, bn plus c. So I told you that if you have this in this format, the b that you see here is a special part. It's just like, remember from our linear equation, from the equation of a straight line, y is equal to mx plus c. This m represents the gradient. It is the same thing as this b here. It represents like the gradient. That is the common difference that you have. Like here, there's a difference from term 1 and term 2, the 6 minus 2, that's a 4. Here there's a difference of 10 minus 6, that's a 4. As you can see, there's a difference of 4 throughout. That is this b here. It represents the common difference. But like I said, if you reach grade 12, we shall use a different formula, but it's the same thing, okay? So this b is 4, so it's going to be 4n plus c. Then to find c, you can use any of these combinations that you're given. Like you can take from the first term. The first term is 2 here. This is our first term, which is 2. So it means T1 is equal to 2. The first term when n is equal to 1. Remember, this is Tn. So you're saying T1, it means n is 1. Tn, this is T1. Tn, n. This is T1. So where there's n, we now have a 1. So it means in place of n, we are going to substitute 1. And this Tn is substituted by a 2. So meaning to say 2 is equal to 4 into n, which is our n, it's 1, plus c. So 2 is equal to 4 times 1, which is a 4 plus c. Then we can transpose the 4 to the other side of the equation. It becomes a negative. That's 2 minus 4 is equal to c, which is negative 2. So c is equal to negative 2. Meaning to say Tn is equal to 4n, all right, minus 2. Let's say it's me who is Letty, because I'm obtaining the same answer as Letty, like this. This is what you were supposed to obtain in your normal simplification. We all understand this, all right? But the question was not for you to do this. The question is for you to use the algebraic simplification for us to prove that these two are the same in our side or not. So this is what you're going to do. The Letty is already in simplest form. 4n minus 2 is in simplest form. So what we are going to do is that we are going to work from from our Zane's answer, all right, which is Tn is equal to 4 into n minus 1 plus 2, because this is not in simplest form. There's a bracket that we have and so forth. So we can work from there and see if we are going to have the same thing as what Letty here got. Okay, so let us do that. We are talking about the expansion of brackets in this case and collecting of like terms. So that means our Tn is going to be distributed by 4. That's 4 times n, which is 4n, 4 times -1, which is a -4 plus a 2. All right, so that means Tn is going to be equal to 4n. Collect the like terms, -4 plus 2, that's a -2. So here we are going to obtain a -2. So Tn is equal to 4n minus 2, which is the same Tn as Letty that we have. So this is the same as Letty's for the one that we have. So both are correct in this case. So in this case, both are correct. Okay, it's one and the same thing. Both are correct. This part, when simplified in simplest form, it gives us the same thing as what Letty obtained. All right, so that is how you're supposed to attempt this typical question to use algebra to justify the answers. Okay, that was just 3 marks for that. And we're given 3.1 to determine the value of the 27th term of the sequence. All right, so we are given n is 27. So what is T27? Already we have got our Tn in simplified form. Remember, we managed to have this in simplified form. We now know that our Tn is equal to 4n minus 2. Yes, we can even use this one. It's one and the same thing. So when they're asking for the term that corresponds the 27th term, we are given that there are 27 terms. They are like n number of terms. They are 27. So we need to calculate T27. So in place of n, we are going to substitute a 27 in that case, minus 2. So that is T27 is equal to, so here you can just use your calculator actually, and this simplification is a straightforward thing. So just 4 open bracket multiply by 27 like this, then subtract 2. This is going to give us 106, that is 106. So this is T27. That is when n is equal to 27, our T is going to be 106. Okay, that was the idea of the question on this part. Then 3.2, consider the following sequence. So there we have got a sequence that you're supposed to consider. Determine the nth term of the sequence. That is, we are supposed to write a formula for Tn. We do not know what is the formula for Tn in that case, all right? So if we are to check properly here, that's 3.21, all right? If you are to check properly, we've got minus 3, 2, 7, 12, 17. Let us check if we have got a common difference in the first place. If you are to subtract this, that is going to be 2 minus 3 is the second term minus the first term. So this means 2 minus, but what are we subtracting? The first term, and the first term is minus 3. So that's 2 minus minus, which is a plus, and 2 plus 3, that's a 5. All right, 7 minus 2, which is a 5. 12 minus 7, which is a 5. 17 minus 12, which is a 5. So as you can see, there's a common difference throughout. So this is a linear pattern that we have, a number pattern that we're talking about. In this case, it's a linear. And I told you that for a linear, for the sake of us not having confusion for our grade 12, for our grade 11, we shall have this as Tn is equal to Bn plus C. So that when you are doing grade 11, you're not going to have a challenge. It's just going to be a continuation, all right? So I told you this B, as long you know what it represents, this B is your common difference. That's your common difference in that case, all right? So if this B represents our common difference, therefore let us substitute, because we have the common difference, which is the first difference in that case, okay? So you're going to substitute and see what you're going to have at the end. So this is going to be written as Tn is equal to the common difference, which is 5 in this case. So that is going to be 5n plus C. So it's just like a linear equation. This is a linear equation, actually. Just like the same way you do it with functions. How are you going to calculate the value of C? You take any of the corresponding points that you're given. So you can even work with the first term. This is our first term, which is -3. So it means T1 is equal to -3. If you want to use the second term, T2 is equal to 2. If you want to use the third term, T3 is equal to 7. So you just use any of the combinations that you want, as long as you understand that if I write the first term, which is T1, is equal to -3, it means N is equal to 1. In place of N, I'm now having a 1. So wherever I see N, I'm going to substitute a 1. So this means I'm going to have 5 times 1 plus C in place of N. But this, after substituting 1, I'm supposed to get what? A -3. So this is Tn. So -3 is equal to 5. Into this, we can find the value of C. 5 times 1, that's a 5. Then we're going to transpose that 5 to the other side of the equation. It becomes a -5 equal to C. So that's -8 is equal to C. So if C is equal to -8, therefore it follows that our Tn is going to be written as, remember we said this whole part, our expression is going to be given as 5n plus C. So this is going to be given as 5n plus C. Our C in this case is -8. So that will be a -8, right? So that is how we're supposed to find Tn. That is the nth term. Whenever they're talking about nth term, they are saying we must write an expression in terms of n, an expression that we can determine whatever that we want in terms of what? In terms of n. Okay, then the other part is 3.2, to determine the value of the 52nd term number to end in a 7. All right, to end in a 7. All right. What are you going to do in this case? We are given already our expression. Then they want us to find the 52nd term, okay? But this is supposed a 52nd number to end in a 7, which is going to end in a 7. So what are we going to refer to in this case? The value of the 52nd number. All right. It is the same thing as what we have here. Determine the value of the 27th term of the sequence. So here we need to determine the value of the 52nd number, but it must end in a 7, to end in a 7. Okay, let us say we are to find this from our expression we are given. In this case, this is 5n minus 8, which is our expression that we are given for the simplification that we have for Tn. So when we are given the number of term as 52 in this case, as we can see here, we are given this as 52. So if we are to given this as a 52, how many which is going to be the term corresponding to these? So this is going to be T52 is equal to 5 times 52 minus 8. All right, so what are we going to obtain from this part? Okay, this is what you're going to have at the end. What are we having? Okay, I'm just going to need the calculator here. So that's 52. All right, so I want you to see here, we're going to have on our calculator, that's 5 times 52 minus 8 like this, and this is going to give us 252. All right, that is 252. So I want you to see what's going to happen in this manner if we were to take it in a way that can be much understood. If we are to consider the number of terms, all right, in this case, let us consider how they want us to have this. If we are to consider to say the 52nd number, where are we going to have like a position that represents this number? What is going to be the position of this? But to the number to end in a 7. To end in a 7. So the question that we're going to ask ourselves is that, okay, the equation that we are going to have is going to change. So meaning to say this is not ending in a 7, this part. Guys, I want you to properly see this. If you check this sequence here, it is of 7. 17, that is, we are having a 7 inside. This is the 52nd, considering all these as they are. So meaning to say, if you answer this here, you have answered the 52nd position for the normal sequence that you were given before. I want you to be clear. For the normal sequence that you already given. So it means the 52nd position where we have a 7, you are going to count properly according, and it's going to be of you to analyze this to say, okay, how many terms like do I have to get a 7 here to get this 7? There are 2 terms, I get a 7. Here there's 1 term to get a 7. So it's going to be complicated for you to count them. So the easiest way is to take a pattern that consists of that 7, because it must end with a 7. So after this 17, we're going to talk about what? 27. Right? 17, 27, 28, 29, 30, and 34. It's going to talk about 37, 47, 57, 60. These numbers, they end with what? 7. So it means there's a new pattern at all that is affected. So this here is not going to work. It's not going to give us exactly what we want. So this is what we are going to do. Numbers, all right? So this is 3.22. Okay, I want you to be very, very clear here, 3.22. Numbers ending with 7. All right. So the numbers ending with 7, according to this sequence that we have, 7, 17 is going to be like that, 7, 17, 27, 37, like I said. So you're going to have something of that nature, 7, 17, 27, 37, 47, 57, 67, and so on and so on. These are the numbers that are ending with a 7. So on these numbers, what is the difference? Because it has changed. Guys, let us know. This has changed total. It has changed. So this is going to have a difference, a difference, a difference zone. But if you check 17 minus 7, that's a difference of 10. 27 minus 17, a difference of 10. 37 minus 27. So there's a difference of 10, a difference of 10, a difference of 10, a difference of 10 throughout. But remember what I said Tn is supposed to be given in the form of Bn plus C, where B is the difference. So we shall have our formula as Tn is equal to Bn, where B is the difference of 10. So this is 10n plus C. So to find C, we can substitute any of the given points that we have from the first term. T1 is equal to 7. So if T1 is equal to 7, what does it mean? It means we're going to substitute this as 7 is equal to here. We're going to substitute a 1. So that will be 10 plus C. Take this to the other side. That's 7 minus 10, which is minus 3 is equal to C. So therefore, the new term, the new nth term, which is Tn, is given as 10n, which is Bn plus C. Our C in this case, which you said is negative 3. So this is a new format at all for Tn, for the numbers that are ending in 7. So now we can find exactly the T52. We say determine the value of the 52nd. So 52. So when n is equal to 52, what is T52 now? That is where we are asking ourselves this question. So that's why I said, guys, be careful on this question, all right? So that means T52 is equal to 10 into 52 minus 3, which is going to give us what? We're going to substitute here everything on our calculator and see what you're going to have. So that is 10 into 52 like this. minus a 3. So this is going to give us 517. All right, so that is the answer that you're supposed to obtain in that case. Like I said, in order for you to have this, we want something that is for the terms that are ending in terms of 7. They're ending in 7777. So what is T52 of these terms? It's no longer the sequence that we used to have this one. This one was starting with -3. These numbers, they're not even ending with 7. We just want to take all those numbers that are ending with 7. So you're taking 7, 17, 27, because there are so many and so on and so on and so on and so on. As long the number to the end in a 7, the number is going to end with a 7 at the end. That is how we are supposed to obtain this. So, all right. So I want you to be very, very careful about this question. So let me know about this question. If you still have challenges on attempting this type of a question, let me know so that we can be able to revise this question together for other questions of this nature that are similar to the same question that we just worked on this question.